Okay.
Oh,
Okay. So what were so number one, you said, Peyton? What about number one is causing you trouble?
it could have been the fact that I was on the sleep.
Okay.
Yeah, I don't know how to do that one either.
Okay. What?
It's a binomial.
I don't know what
A binomial?
Yep.
What do you
Bi
think the
means
prefix?
two.
There we go. Bi means two.
Yeah.
What do you say
How
about
many numbers are in each of those parentheses?
Two.
There's only one number?
Yeah, there's
Remember,
one.
a variable is just an unknown number.
Oh my gosh, so two.
So two.
So you
Right.
multiply both of them by 2?
Say that one more time.
Do you multiply both of them by 2 or something?
Do you see multiplication by two?
No.
No.
I don't know what I see.
Did you read the directions?
Yeah, multiply 2 binomials.
Did you read the directions that gave you clear instructions of how to do that?
Oh, okay, I was wondering.
Plus, we've done this over the last few days in class.
Yeah?
We had.
Yep.
I wasn't paying attention.
I could tell. Now, it was part of the previous ready homework, but we talked about this. It says multiply the two binomials, but if you look at the instructions as well, what does it say in those instructions? What are we supposed to do? It's a really important word that starts with a D.
Distribute.
What should this x be multiplied by to distribute
The
it?
5,
X
the
and
other
7.
X, and the 7.
Is that x being multiplied by 5?
No, it's being added. What you're gonna do is add it, or I'm sorry, multiply it to the x and to the 7, creating x to the second because it's repeated multiplication.
Well, hold on. Just stop,
Alright.
slow down and notice that, right? That x needs to be multiplied by x minus 7. What do we need to do with the 5?
Times x times 7.
Right? We are distributing that x and that 5 to the x minus 7 and the x minus 7. Or just to the x minus 7. Notice that should remind us of the ready section from 6.2, doesn't it?
Yeah,
Yeah.
Yeah?
yeah.
Now, what am I going to do at this point, Peyton? Because you were saying this already.
Multiply out the x by the x and the 7.
Okay, what is x times x?
X squared
Square.
X times negative 7?
minus negative 7x.
So minus 7x.
And then 5x minus 35. And then add that together, you're gonna get x squared and then 35.
Is good minus
X squared minus what?
2,
minus 2x
and then 35.
minus. It's not 30. Oh yeah, 35 is.
Oh crap. Okay.
Notice, it's just like we did on the previous set of homework. We're just distributing. Devin. Thank you, sir. Any questions about number one before we continue?
Yeah.
What's number 1?
No, on the homework sheet.
Okay, what are you saying? Correll?
Number 10 is 1?
Yes, number 10 was one?
I don't know if you meant that
Number-
number one.
number-
I didn't have a problem with that.
Gotcha.
I was on the rush.
Hey, Correll, what were you saying?
17.
17 gave you trouble? Can anyone explain to us how I got these numbers in 17 maybe?
So it says f of 0 is equal to negative 5, so that means the zeroth term is negative 5, and then f of n is equal to f of n minus 1 plus 8, which means the rate of change is plus 8. So you start at negative 5 at the 0 turn, so the first term is going to be positive 3, and then 2, and then you're going to add 3 and 8, which is 11. Then 3, you're going to add 8 and 11, which is 19. Then 4, you're going to add 8 and 19. You get the point.
Does that make sense, Corell?
Because if you look at the recursive, remember that the back, like the right side of it's going to have the rate of change, and it's plus 8. F of n is equal to f of n minus 1, and then it's going to be whatever it's doing. Because remember, it's current and previous, so it's going to be plus 8 for the rate of change. And then it says f of 0, so on the 0th term, it's going to be negative 5.
Does that make sense, Corell, or do I need to go with that? So I think Payne did say that very well of, hey, this is our current term, and it's equal to our previous term, but we're adding 8 to it, right? That's all it is. And so if I want the first term, I need to add 8 to the previous term, the 0th term.
Hey, oh wait, never mind. We got 18, didn't we? We didn't have to do 18?
Not last time.
Oh, well, I did it, so can we do it just to show?
Nope, because we will have that unless you as homework either, I think it's tomorrow night that we'll have that as homework. Number 10. Did someone say we need to talk about this one? Or are we good?
10, no.
10, we're all good? Okay. Say again, the second part? That gave some of us trouble for sure.
Yes, so.
Yeah, so that was
I
irritating.
I forgot how to do this.
What did you do for that? Because that was irritating. I got that wrong. I did.
Were we good on the first or the second inequality?
Okay.
Yes, I got the first one.
I did the rate of change right. I got the thing wrong. So, okay, that's cool.
So, wait, say that one more time.
Just work that out, please, because I got it.
Work what out?
The inequalities.
Which one?
Top.
The top one up here?
Mm-hmm.
Okay, so I will ask this, 2x is greater than or equal to y minus 1. That looks different than what we're used to, but what are we used to doing to graphing an inequality?
Equal. Equations.
Okay, we're used to equations, yes, but how did we graph those linear functions or
What do
the
you mean?
linear inequalities?
Substitution.
That's how we identify the solutions, I believe, but that's not how we... How did we graph a single inequality?
Oh,
Could I find x and y intercepts here?
yeah.
Because what do I know every time I'm looking at an x-intercept? Could you have done that here, even though it's not in standard form?
Wait, slow down, I'm not paying attention. Okay, now I'm paying attention.
Could I have let y equal 0 to identify the x-intercept, even though it's not in standard
I
form?
mean, yeah, but it'd be 2x is less than, oh crap.
So you could have done 2x when you want to do equals for the intercepts, right? You could have identified the x-intercept. What about for the y-intercept?
Wait,
What do we know?
Oh, I forgot about
X
that.
equals 0.
X equals 0, right? You could have done the same thing, but 2 times 0 is equal to y minus 1. So you could have found your intercepts and graphed it that way. Not necessarily what I would have recommended, but you could. Go back to the fundamentals. Hey, I need my x and y intercepts. Cool. But personally, what's another strategy that we use to graph inequalities?
Hmm.
2x and then y minus
Didn't we convert it sometimes?
Yeah,
So what?
slope intercept.
To slope intercept, didn't we? Slope intercept being y equals...
And x equals b.
Hey, I want you to notice what variable is completely on its own.
Y.
y. Oh, you gotta get y in some, so you add 1. Oh my Jesus, so smart.
Negative 1 plus 1.
0.
So 2x plus 1 is greater than or equal to y. Or you could reverse it, y is less than or equal to 2x plus 1. No matter what, like your slope is 2, your y-intercept is 1. And then you just have to identify which half plane of...
Wait, which one is my intercept?
What do you think?
Oh, never mind. I was looking at it backwards.
I mean, even if you looked at it like this, 2 times x, that multiplication is my additive rate of change.
Yeah.
And b is 1, or 0 comma 1.
So at the point 0, 1 is your y-intercept. And
Yep.
then you go up 2 to the right 1.
Yep.
Oh my gee.
That's all it is. Down 2 to the left 1. And so you do need to justify why it's a solid boundary line, but then, again, why am I shading below that boundary line?
I got the slope right, but I got the x intercept wrong. So.
You mean the y-intercept?
No, I mean the x.
You mean the y? Oh, I just said it.
Okay. But regardless, right, why am I shading below this boundary line?
Because I'm on the go below, that's where the solutions are.
We know the solutions are below. Focus on that word solutions. That means these points below the boundary line make the inequality
True.
true, right? You can test those points to see that, right?
Facts.
Now, notice my strategy for when it was in standard form
I need help on that.
was just x and y intercepts. Personally, if I have standard form, x-intercept, I know my y is 0. 2x minus 5 times 0 equals 10. I got my x-intercept. And if I want a y-intercept, I know that x equals 0. Right? We've done that a good bit. So my y-intercept was 0, -2.
I remember now, my G's. It's bringing back memories. I'm not good.
So I do want you to notice that, Kelsey,
Yes.
mascot,
Swearing, sir.
this should be bringing back memories. And I know it's been a few weeks since we've done this, but that's why I'm doing what's called spiraling, bringing back those old problems to help us re-practice those skills. One, it doesn't matter when you learn it, it matters that you learn it. So we can always improve those skills too. If we never did this again, would you remember it?
No, not at all.
No.
Nope, not at all, not even the slides. That's why we're reviewing and spiraling back those ideas.
Wait, no, that's actually called something?
Yeah, when you bring those old skills back and you keep repeating them, you spiral back to them.
5-0.
And then, again, the solutions are above. I checked a point right here and made the inequality true. That was this point.
Why do I feel like you researched the spiraling thing?
So why am I shading this region right here?
that's
Because
the
the
solution for
overlapping is shaded both, but it's same for both.
The overlapping shaded region, which means that's where the solutions for both inequalities are. Alright? We need
Wait.
to,
Slow down, I
Move
gotta
on.
write it down.
you know, these slides go up on Schoology every day, right?
Oh, true.
I'm not trying to be mysterious, like, this stuff goes up, I have all those
Oh my
tutoring
geez, I
sessions.
just copied the one.
I'm also, you know, putting the videos online.
Ew. Okay, whatever, I'll just stay off of Schoology.
Okay. I know. I just wasn't even gonna worry about it. So we're gonna look at our objectives, and then we're gonna get back to combining linear and linear functions. Okay. So what are our objectives? What are we trying to do? Like, obviously, we're using these SMPs to help us get to these objectives. What are we trying to do with this Desmos activity?
You're trying to make our life difficult.
You are 100% right. I want to make every single one of your lives really hard. That's all I care about.
Yep.
Yep.
Well, at least you admit it.
Yep, 100%. You got me.
Definitely not being sarcastic.
Definitely what I'm trying to do. No, come on. Let's actually think for a second. Because that's when your life doesn't become difficult, because you learn how to think. I know, it's such a rough
With the
time.
Desmos activity, you're learning, you're teaching us a few things. I don't know exactly which one you're trying to hit on right now, but you're teaching us how to use resources to make our life easier, how to use, at this current moment, how to combine linear functions.
Okay, let's stop right there.
to
What are the objectives? That's what I literally said.
Combine linear functions. to create a-
Right! Like, don't make it more difficult than that. What do I mean by combining linear functions? I am adding,
Add,
subtracting,
divide,
multiplying,
multiply.
dividing, right?
You're cutting it into like 8 different pieces. You know,
Okay, but we're just talking about trying to combine, add, subtract, multiply, and divide linear functions. When you add, subtract, multiply, and divide linear functions, what are you then trying to do?
Figure out what they
See if
created.
it's linear or quadratic or exponential
Right?
or
Or undetermined.
Or undetermined, something we haven't learned before, right?
I know one that we don't know.
Squiggle.
It goes squiggle, squiggle.
It's squiggle with S.
Are you talking, does it look like this?
Squiggle, squiggle.
Squiggle, squiggle, squiggle.
Yeah.
Yeah.
We've talked about those.
Oh, yeah.
We haven't. They're called sinusoidals. They're
Yes,
sine
that.
and cosine functions. You'll study
I
them in
saw it on
algebra too.
TikTok.
We saw TikTok.
Cousin sent it to me.
You saw it on TikTok.
She said, why are these
Man, at least you're learning some math on TikTok. Ugh.
No, they're stalking us right now. They know that we've been doing linear and quadratic,
Okay?
exponential. Oh.
So, but the focus is when we add, when we subtract, is it creating linear? Is it creating an exponential? Is it creating a quadratic function? But also think about how are those intercepts interacting. Is everybody logged in to Desmos with this code, UJFE4H?
Yes.
Good.
Okay? While some of y'all,
I could have promised you gave me one too. I don't know why.
so while Corel is getting in, all those things, really quickly, and some of y'all are probably still getting into Desmos, make sure you get there. I do want to remind you and ask, because it's important that we understand how the sliders work. When we looked at A and C for f of x and g of x, what did A and C affect or change for those functions?
Slope.
Okay? Layla, why should it make sense that A and C were the slope? Why should it make sense that A and C are the slope of those two functions? Perfect, right? Y equals mx plus b. That is my slope. So that A and C, whatever the value for A and C were, those are the slopes for f of x and g of x, right? So Kelsey,
Yeah.
what did B and D affect?
That's our intercept.
Which intercept?
Y.
Y intercept, right? Because again, this is what equation of a line?
What's not slope intercept?
Slope intercept, right?
Yes.
So we got our slope and we have our y-intercept in there. So do not forget that. We are trying to combine linear functions. And I believe everyone got through a sum yesterday, correct? We did not all get through f of x plus g of x? Y'all did not? Are you sure?
got to 13.
My paper is blank.
You didn't write it down. You typed it into Desmos.
Oh, maybe yes.
We will start writing it down tomorrow when we come into class. But we already did a sum of two linear functions. How many of us already got to a difference?
I got to 13.
Wait, which slide is
Was
it?
that difference?
Yeah, difference.
Okay, so we're on difference. So let's try to get all the way through quotient today. We should be able to get through quotient today. What?
He didn't do it, so I gotta catch him up.
You weren't here yesterday. What are you doing? Pick up with difference. Just don't. We'll talk about sum altogether. Focus on just difference with them. Okay. All right. So let's go ahead and get started on our differences. What does that look for?
I'm a genius.
You're a genius.
Yeah.
Tell me.
All right. Well, you better talk about it with your group to make sure that they understand as well.
Tell me.
Doesn't matter how smart you are. It matters that you all learn it. And Kelsey, you're in a different group, so you talk with your group to
She's
figure
giving
it
me
out.
answers.
Because I'm pretty sure.